Hello everyone. Today I, Shalu Kapoor, am teaching you the electric potential. The electric potential due to dipole and a number of charges. Right? So let's discuss electric potential due to dipole. Before discussing this topic, I would like to tell you what is electric potential. Electric potential is represented by V, and it is the amount of work done to move unit positive test charge from infinity to a particular point in the electric field of source charge. And mathematically it is potential V is equal to KQ by R, and it is a scalar quantity. The potential, it is a scalar quantity for positive charge. The potential is KQ by R, and for negative charge the potential is K minus KQ by R. Now, what is a dipole? Dipole is a system of two equal and opposite charges. It is system of two equal and opposite charges separated by a small distance. It is called as electric dipole. So, system of two equal and opposite, that means let's say this is plus Q, this is minus Q, separated by small distance, and this distance is represented by 2A. The center of these two charges, that is called as center of the dipole. Here I am representing it with O. Strength of the dipole, that is represented in terms of dipole moment, which is represented by P, and it is a vector quantity. The magnitude of P is product of either charge and the distance between the two charges. Here the magnitude of charge is Q and distance between the charges is 2A. Therefore, dipole moment, the magnitude of the dipole moment, which is a vector quantity, it is Q into 2A. And the direction is from minus Q to charge to plus Q charge. And SI unit for dipole moment, it is, because it is product of charge and distance, so SI unit is coulomb meter. For potential, the SI unit is volt, and 1 volt is equal to 1 joule per coulomb, because it is work done to move unit positive test charge. So it is 1 volt is equal to. This is the introduction. This was the introduction about the terms which we will use, because we have to find out electric potential due to dipole. So we must be aware what is electric potential and what is electric dipole, so that we can easily derive the relation for the electric potential due to dipole. Now let's find out, derive the relation for electric potential due to dipole. Since your electric potential, it is a scalar quantity, so the scalar sum, algebraic sum is applicable. For dipole, we will consider these equal and opposite charges plus q and minus q separated by small distance. That distance is represented by 2a. This O, it is the center of the dipole. Right? Now we will find out first of all on axial line. Electric potential on axial line. Axial line, it is the line which passes through both the charges, center of both the charges, and it is can be extended towards the left as well as towards the right. Now let's consider P point on axial line. We can consider it on the left as well as on the right, wherever you want to fix that point. Let's say I have fixed this point P on the right side of the dipole, which is at a distance r from the center of the dipole. This distance from O, this is your r. Now first of all, we'll find out potential at point P, potential, electric potential at P due to plus Q charge. So it will be using the formula KQ by R. So it is KQ by distance. Now what is the distance between the positive charge and this point P? Because this is the center, so this positive charge is at a distance A from the center. This is also A. So this distance is R plus A. So it is KQ upon R plus A. Now potential at point P due to negative charge minus Q, again it is equal to KQ, because this is negative charge, so I will write minus. Now the distance, since minus charge is at this and the distance between the minus charge and P is R minus A, because P is at R distance from O, minus Q is at A distance from O, so this distance will be R minus A. So I will write R minus A. Now potential at point P will be because of both the charges. So total potential at point P, it is potential due to positive charge plus potential due to negative charge. Let's add these two equations. This is equation number 1, potential due to positive charge. Equation number 2, potential due to negative charge. So we'll add these two equations. The result will be KQ into 1 by, for positive charge it is R plus A, for negative charge it is minus 1 by R minus A. Let's solve using the formula. Here take the LCM. A plus B into A minus B will be A square minus B square. So LCM is R square minus A square. And the result what we'll get after solving this, R minus A minus of R plus A. Now I will solve on this side. I will rub the initial portion of the derivation. Yes, so the total potential at point P is now KQ R minus A minus R minus A upon R square minus A square. So the result it is equal to K Q R cancel out, minus 2A upon R square minus of A square. This Q minus 2A, as we know that magnitude of dipole moment, it is Q into 2A. So potential, it is K P. If I will say the, because there I will write this Q into 2A, I need the magnitude only. So Kp upon R square minus of A square. Now this negative sign, yes, of course this is negative sign. Why this negative sign has come? If I will take this negative here and positive here, this negative sign will not come, right? So this is your, because the negative sign, it is, your point P is close to this negative sign, and the potential, it is the distance of negative charge, it is close, lesser as compared to positive charge from point P. So that's why this negative charge, it is in the result. Now this is the result for the dipole. If we consider the ideal dipole, for ideal dipole, what is an ideal dipole? Ideal dipole or short dipole, is that dipole in which your R is very large as compared to A. Means the point P which you have considered, where we want to find out the electric potential, it is very away from the center of the dipole as compared to the distance between the two charges. So then in equation 3, we can ignore A in comparison to R. So this Vp, it is Kp by R square. So potential, it is inversely due to dipole at a point, it is on the axial line, it is inversely proportional to R square. I told you that this negative sign is just signifying that this negative charge, it is close to P in comparison to plus Q. If we keep this negative charge away from this point P and positive charge close to it, this value, this sign will be negative. So this is all about the electric potential due to dipole on the axial line. I hope the concept is clear to you. Thank you.